Hey there, my name is Emiliano. This is going to be a long video, but if you're preparing for the IMAT, the HUMAT, the BMAT, the UKCAT, or any other medical admissions test that has a logical problem solving, reasoning, language skills, anything like that that's not scientific knowledge, like chemistry, physics, or anything like that, this video will help you and it'll be worth every minute. I will leave the timestamps down in the description below so you can navigate and skip around. I will show the questions without the answer if you want to try to answer them yourself, and I will leave a link in the description of where you can find the 3000 question bank for these logical reasonings, problem solving, etc. questions. This is the guide I kind of used to pass my medical admissions test, the HUMAT, which you can look at up here. And right now we're going to look at the logical reasoning, problem solving, thinking, etc. skills that you are going to be asked for admissions tests. You can't really study these because they are like logical and it's not like maths or science, but you can practice. Now, to give you an idea of the questions we're going to look at, well, this is one, this is another, that's two more. So yeah, they're not really that easy, but we're gonna go through 20 of them, I think, and yeah. So this is the first question that we're gonna look at out of 20. Pause if you want to solve it right now. I'm gonna read it out, and then I'm gonna slip to the next page and we can see the answers, and I'll take you through the explanation. So you can see first the shapes. There is 12 different shapes, and the question is, the three terms, numbers between 1 and 22, numbers between 5 and 11, and even numbers divisible by 7 are connected by a specific set relation. Within this relation, 4 can be found in the black part of. So what we have to do is we have to find 4, or where 4 would land in the black area of any of these, with each different circle being a different relation, so to speak. So if we flip to the next one, we have to find numbers between 1 and 22. Well, we have to find 4. We have to find the number 4. Let's find the number 4 in the first relation, numbers between 1 and 22. We find that 4 is inside of 1 and 22. Then moving on to the next relation, we find that 4 is outside 5 and 11. However, 5 and 11 is inside 1 and 22. So right now, we know that 1 and 22 is a big circle. We know that 4 is inside, somewhere inside. This is number 4. We know that 5 and 11 is a smaller circle that is completely inside, because 5 and 11 are inside 1 and 22. And we know that even numbers divisible by 7, well, we know that 4 is an even number, but it's not divisible by 7, so it is outside. And the only even number divisible by 7 that fits within this category and this category is 14, because 28 is bigger than this, and 7 is an even number. So even numbers divisible by 7 will have no overlap with this area, with these numbers, and it will have a small overlap with this category. So it'll be something like this in some direction. So because it is partially inside. Now that we've drawn everything out, if we were to find where the 4 is, well, it's not inside 5 and 11, so it's not here. It's not inside the even numbers divisible by 7, so it's not here. It is inside the 1 and 22, so this is the area that should be colored in black. And if we look at these, well, we should discard the ones that aren't listed, so it can't be. So if this is listed, 3 is listed, 6 is listed, 7 is listed, and 8 is listed. So none of these work, so don't let them confuse you. Now, if we look at number 1, this one is not it because it does not correspond with our shape. This one is not it either because it doesn't correspond with our shape. This one isn't either because it doesn't correspond with our shape. Neither does this one. And this one, number 7, does. So this is the correct answer. Now, moving on to question number 2. This one might be slightly easier to understand. Which, among the terms given, correctly complete the following verbal proposition? Tie, you read this as is to. So tie is to neck as X is to Y. We have to fill in the X and the Y. Pause if you want to solve by yourself. Go. So we know that tie is to neck. And then let's go through the process of elimination from E all the way to A. Trousers is to belt. This is related, but none of these are a body part, which is important. You have to kind of infer the categories here. Bag and backpack, bag and shoes and shoe polish aren't really related to each other and to the prompt. So we're left with watch and wrist, which makes sense because watches and ties are both accessories and wrists and necks are both the body parts where you wear the accessories. So again, it would be A. Then number 3 is something similar. Instead of having 2 unknown variables, you have 1 single unknown variable. Now, which among the terms given correctly completes the following verbal proportion? Swallow is to bird, as dolphin is to what? Well, here you have to know that swallows are a type of bird, and we have to see what dolphins are. So dolphins are not sparrows, because those are a type of bird. They're not whales, because whales are their own different species. Dolphins are not fish, and they're not shellfish either. Dolphins are mammals. So we're only left with A. Swallows are to birds, as dolphins are to mammals. Moving on. This one is quite tricky. I encourage you to pause so that you can solve it for yourself if you want to. All postmen are cheerful. Patrick is a motorcyclist. All motorcyclists are cheerful. On the basis of these statements, which of the following is not necessarily true? Now, so we have to really think about these first 3 sentences. All postmen are cheerful. Patrick is a motorcyclist. All motorcyclists are cheerful. And then we have to think about the actual question, which is not necessarily true. This is really important because not, well, there's a negation. It's gonna dictate what you're looking for. Necessarily is like the conditional, not necessarily. And then true is the state of what you're looking for, whether it's true or whether it's false. And it's the necessarily here that makes it way more difficult. I've drawn it out here. All postmen are cheerful. Patrick is a motorcyclist, and all motorcyclists are cheerful. Let's see. Some postmen may be motorcyclists is possibly true. We don't know, because some motorcyclists don't have to be postmen because they're both independently happy or cheerful. There are no sad motorcyclists is true because all motorcyclists are cheerful. Those who are not cheerful are not postmen. That's true because if you are a postman, then you are cheerful. And then Patrick is cheerful is true because Patrick is a motorcyclist, and all motorcyclists are cheerful. But Patrick is a postman. That is not necessarily true because Patrick is a motorcyclist and not all motorcyclists are postmen. It's convoluted, but it makes sense if you think about it. And then moving on to the next one. This one is also like verbal trickery. They're hard. I know they're hard. It took me a while to understand them. Anyway, read this. I'm gonna read it out and then I'm gonna flip to the next question. If you practice on the computer diligently, then you will pass the final test for the European computer driving license. Only if you pass the final test for the European computer driving license can you obtain the European computer driving license. If these statements are true, which of the following is certainly not true? Now, if you practice on the computer diligently, then you will pass the final test for the European computer driving license. Only if you pass the final test can you obtain the license. If these statements are all true, which of the following is not true? E says, passing the last test for the European computer driving license is a necessary condition for obtaining the license. Now that's true, and we're being asked for something that is certainly not true. So this can't be it. Then, if you obtained the European computer driving license, then you passed the last test for the European computer driving license. Again, that is true, so we're not looking for this. So C, practicing on the computer is a sufficient condition to pass the last test for the European computer driving license. This is somewhat true, but it's not certainly not true or certainly true. So it's somewhere in between, because practicing on the computer is sufficient, but it's not necessary. So B, if you do not pass the last test for the European computer driving license, then you did not practice on the computer diligently. That is true, because you kind of need to practice on the computer diligently to pass the examination or the test for the European driving license. And then A, if you obtain the European computer driving license, then you practice on the computer diligently. That is certainly not true, because practicing on the computer diligently is not a passing requirement. It's not linearly related, so to speak. So you don't need to practice to pass. If you practice, then you'll pass. But if you don't practice, it doesn't say you won't pass. So moving on. Again, pause if you want to solve this by yourself. This one is also a bit confusing, but this is what you can expect. If O then H, and if H then M, and only if M then N. If this statement is true, then it is certainly true that if O then H, and if H then M, and only if M then N. If this statement is true, then it's certainly true that. If we draw this out, so to speak, we know that O implicates H implicates M, and N also implicates N. If N then H makes no sense, because N only implicates M, so it can't be this one. If we look at C, if M then O makes no sense, because O isn't the only thing that can cause M. N can also cause M. So we might have an M but have no O, which makes sense. We know that if N then O makes no sense, because N only implicates M and is not related to O whatsoever. And we know that if not M, then not O, because O implicates H, which implicates M. So O does, in a roundabout way, implicate M. If we move on to the next one, this is somewhat tricky, but it's way easier than the last few we've seen. Pause. Identify the alternative that does not fit with the others. So here you might, it's somewhat confusing when you're being asked, because, well, if you look at it visually, you can see that, okay, Milan, Stockholm, London, Vienna, Oslo, they're all cities, they're all in Europe, so they all have that in common. And Oslo is the only one that start with a vowel, so you might be inclined to think, oh, it's Oslo, but it's not. Stockholm, London, Vienna, and Oslo are all capital cities, and Milan is the only one that is not a capital city. So the alternative that doesn't fit is Milan. Moving on here, once again with the verbal trickery and the grammar to confuse and confuddle. Pause. Medical research has not helped to demonstrate the impossibility that gastric ulcer is a hereditary disease. Which of the following is the correct meaning of this statement? Alright, so we have a double negative here. Not and impossibility are both double negative, so they sort of cancel out, but they do modify the statement. Medical research has not helped to demonstrate the impossibility. So medical research has not aided in demonstrating whether it's possible or impossible that gastric ulcers are a hereditary disease. That means that medical research hasn't been very useful in showing whether ulcers are hereditary or not hereditary. It hasn't really said anything. So if we're going to find the correct meaning of this statement, we have to find one that takes into account that nothing certain can be stated about the gastric ulcer yet, because medicine or medical research hasn't helped in that. So this one says that medical research has demonstrated that the ulcer cannot, so that is not uncertain, so this one is out. It is impossible that a gastric ulcer is a hereditary disease is also out, because it is stating something certain. Medical research does not always have the answers. That is true. but it's not the meaning of the statement. So it's out 2. Medical research has demonstrated that gastric ulcer is a hereditary disease, is again making a bold claim, which we don't like. So we're left with A. Medical research has not demonstrated that gastric ulcer is not a hereditary disease. So here with the double negative, again, this shows that there is a possibility that it might be hereditary or it might not be hereditary. But anyway, this is the right answer. Then, wow, these are all very, very hard, guys. So don't be like nervous or scared or anything like that if you can't do these. It took me like so much practice to even come up with the answers for this, and I procrastinated so long on filming this video because I know that I don't really fully grasp these yet. So while I am explaining to the best of my abilities, it is still really hard, and these are really challenging questions. So don't be afraid don't be scared or nervous if you're not getting these or if these seem impossible. They did to me too at the beginning. All you have to do is practice. But anyway, I'm gonna read this one. Be sure to pause if you want to solve this by yourself. The legal provision that exempted Italian politicians from incompatibility between their office as members of the Italian Parliament and that of members of the European Parliament has been revoked. Which of the following is the correct meaning of this statement? So here we have 3 negatives, but they're all talking about kind of different things. So the legal provision that exempted Italian politicians from incompatibility between their office as members of the Italian Parliament and that of members of the European Parliament has been revoked. So first, before choosing an answer, we have to understand this statement. There was a legal provision that exempted Italian politicians from incompatibility. That means that there was a law that allowed Italian politicians to be both members of the Italian Parliament and members of the European Parliament. But that now that has been revoked. So that means that if the law that allowed Italian politicians to hold 2 offices has been revoked, it means that now Italian politicians can only hold 1 office, and that now both offices are incompatible with each other, so you can't hold both anymore, even if before you could. So if we look at the answer starting from A, Italian politicians may either hold the office of members of the Italian Parliament or that of members of the European Parliament. That is correct, because they can only hold 1 now. Before they could 2, now they can only hold 1. Italian politicians can all hold the office of members of the Italian Parliament. That is not certainly true, or that is not the correct statement, because they can if that's the only office they're holding, which is the same case for C. Not true. They may hold both the office of members. That is not true. They can only hold 1 now. Before they could both, now they can only do 1. And there was a legal provision that prevented Italian politicians from holding the office of members of the Italian Parliament, and at the same time, that of members of the European Parliament is false. There was a legal provision that said that they could hold both at the same time. So we are left with A as being the correct answer. This one is kind of a break. It's relatively easier. I added this one so that you all could see that you do need to have some sort of dominion over the English language and synonyms and stuff like that in order to do well in these tests, because this, while might be easy to native English speakers, could prove quite difficult to somebody that is not a native English speaker. But yeah, 3, 2, 1, changing. Which among the terms given correctly completes the following verbal proportion? Tenacious is to stubborn, as tenacious is a quasi synonym to stubborn. They both need more or less, they both mean more or less the same thing, or are things that are relatively interlinked. So to answer this, you kind of eliminate things that are not synonymous or that don't go together. So powerful and faint don't go together. Fragile and sturdy are antonyms. Reckless and shy do not go together. Strong and weak do not go together. And you're left with quasi synonyms unfit and incapable, which are more or less the same thing. Now, answer the following question concerning image SB83, which is this one. Find the figure that completes the series. So you won't only be asked like English stuff, you'll be asked about visual stuff too. Pause if you want to complete on your own. So a lot of text here. Eliminate the ones that don't make sense. So try to find a pattern is the first order of business here. I'm gonna erase this and then I'll explain why. So here, ignore my scribbling right now. If we look at the red squares, they are all moving in a certain direction. They're all moving down, right? They're all moving down in a straight line. So if you see the squares, the black square is moving down because the series does go in this general direction. So the next thing that makes sense is that it would move to the right. I'm sorry, to the left. That the black square would move in this direction. So this doesn't make sense because the black square is moving like this. This doesn't make sense because it's moving like this. And this doesn't make sense because it just jumps completely. These two make sense because the black square moved from here to here and from here to here. So how do we choose between the two? Well, that's where the numbers come in. If you look at the squares, there's 4 by 4 squares, and you can look at the two letters. You can say that, okay, A, B, C, D, A, B, C, D, and they act as coordinates. So A, B, AC, AD, etc. And then the actual letters are in the square that belongs to those coordinates. So here we would have BA, BB, BC, and here where the BD is, you would have BD. And here, in a completely different square, we would have, so say AA, BA, CA, DA. So this matches. And then AA, BA, CA, and here we have AD, BD, CD. CA, CB, CC, CD. So the coordinates have to match with the letters. So here we have CA, CB, CC, but we have DC. And here we have AD, BD, and this is wrong because it should be CD, but it says DC. CA, and this would be BC, and this would be CC, which it is, but just to make sure, this is CA, this is CB, this is CC. So these are in the correct, and so that this one is the right answer. Now this one was surprisingly easier than I thought, but it's still like another question we haven't yet seen or explored. Pause if you want to. What is the probability of drawing a 3 or a sword card from a deck of 40 playing cards? So you do have to have some sort of background knowledge that playing cards are divided into 4 different suits. So in 40 playing cards, you will have 1, 2, 3, and sword, for example. And they are equally divided, so each one will have 10. You will have 10 of each that go from number 1 to number 10 in each suit, so that's 40. So that means that of 40 playing cards, if 1/4 are sword cards, that's 10 sword cards. But if there's 4 suits, that means there are 4 number 3s. So that's 10, plus each one of the suits will have a number 3 card. So that's plus 4, so that's 14. But one of the 3 cards is a sword suit, so you don't really count it. So that's 14 minus 1 equals 13, because you have 3 3s, and then all of the sword cards, which include a 3 card, right? So that's 13 out of 40, which is the answer we have here. And let's move on to the next one. This one was fun. I like these, but it's confusing as heck. So, pause if you want to. I'm gonna call this beta. Beta. This is money. This is at. Just to make sure that we're clear on the terminology. Beta, at, and money, all right? So if beta plus at minus money equals 25. And then 2 times beta minus money equals 25. And 5 times at equals 25. Then beta equals, well, let's see what it equals. So you have to identify the terms here. First, you have to make sure that because beta will equal the same thing here and here, it'll be the same number, and at will be the same number here and here, and money will be the same number here and here. So it's important that you establish the numbers. So first, let's start with the simplest equation, this one. 5 at equals 25, which is right here, means that at equals 25 over 5, which means that at equals 5. So we already know that at equals 5. And then we can substitute at equals 5 in the only other equation where at appears, which is here. And we have beta plus 5, which is the at sign, minus money equals 25. And then what we're gonna do is that we're gonna leave beta on one side of the equal sign, and then 20 plus money on the other side. Because that way we can substitute beta into the third equation that we have, which is this one. We're gonna put beta into, all the way into this equation. So, which is what I've done here. This is beta, all of this is beta, times 20 plus money minus money equals 25. And then if you do the equation thing, you have 40 plus 2 money minus money equals 25. And here, money equals 25 minus 40. That means money equals minus 15, negative 15. And then this leads us over here, where we can substitute the money back into this equation, which we just put in the other equation, in which beta plus 5, which is the at sign, minus, and here the parentheses are very important because you are adding a sign that is negative 15, minus parenthesis, minus 15, which is money sign, equals 25. And if you solve for this, well, then you know that minus times minus equals plus. So this becomes plus. So beta plus 5 plus 15 equals 20 equals 25, which leads us to this, where beta equals 25 minus 20, beta equals 5, and that is your final answer. So here beta equals 25. Moving on. Again, this is like spatial reasoning. It's weird. Just pause if you want to. If you have a scale with 2 platforms, the left arm of the scale is 3 times the length of the right arm. 24 identical weights are placed on the right platform. How many weights of the same kind must be placed on the left platform to balance the scale? So you have a scale with 2 platforms. So you have, this is your fulcrum, the place where the scale moves. And the left arm of the scale is 3 times the length of the right. So you have 1 unit here, and then you have 1 unit here, 2 units here, 3 units here, right? So this is 3 times longer than, this side is 3 times longer than this side. If 24 identical weights are placed on the right platform, how many weights of the same kind must be placed on the left platform to balance the scale? If you have 24 here, this will tilt in this direction and this will go up. You want to know the exact amount of weights that have to be placed here so that this goes down and this goes up, and you achieve equilibrium. It would be 24. If you're moving in this direction, it would have to be 1/2 of 24, so 12. And if you're moving 3 times, then you divide 24 by 3, which is 8, and you have to put 8 here, and that should eventually level these. So the correct answer is A. Okay, this one was interesting. Procedural thinking. The personnel of a company are asked to take a test about their habits. One of the questions is about the medium they prefer to get news from. Results are obtained by comparing 3 different media 2 by 2.
and always asking which is the favorite between the two. The research thus aims at establishing an order of preference among staff. T equals television, N equals newspaper, and I equals internet, all right? By following the chart shown in the figure, find the order of preference corresponding to each square. So here what you have to do is you have to find the order of preference between I, N, and T, resulting at box 1 of the diagram. So first step is identify box 1 right here. And so this is box 1. Next step is that we want to identify where we want to identify the path it takes to get there. So we start between T and N. If N wins over T, and then I wins over T2. If that is true, then we arrive at box 1. All right, so that makes sense. So T versus N, and N wins. That means N, we prefer N over T, right? So this is better, this is worse. And now, okay, so this is what we have, and if I write it right here next to it, we can move it along to right here. Okay, so I also wins over T, so now we have these two, I over T. So we have these two different things. We both know that people prefer both the internet and the newspaper over television. And then we arrive at the square. So what gives? Because it can't be either of these. It can't be ITN. Well, we know that T has to be at the end, so the only one that we have left is this one. And we don't know whether people prefer the internet over the news or the news over the internet. So we can't really answer with this one, but we can show a order of preference. So it's not this one. More than one order of preference can be determined because it'll either be N, I, T, or remove this, or I, N, T. But as of this step, we can only achieve here where both N and I are above T. That is all we know, so more than one order of preference is possible. This one was quite logical, so to speak, at least if you've ever seen a pulley and you know how it works. The system shown in the figure is in its starting phase. All the metal balls have the same mass, and the mass of the cable is negligible. So don't worry about how much this weighs or anything. And here we have 1, 2, 3, 4, and here we have 1, 2. So obviously this side is heavier and this side will pull down. Answer the following question concerning image SU15, which is this one. If the answer is only subjected to the gravitational field in the absence of friction, then it may be concluded that. So here we have more weight here because we have more balls, and here we have less balls. Now the easiest way to find this out is literally to figure out which way each one of these is going to go, because you're being asked about different pulleys. So this has more weight, then this is going to go in this direction, which means this goes in this direction, which means this goes up, this goes down, 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 and this goes up because this has less weight. That means this rotates in this direction, 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 and so on and so forth until you have the rotation of all of the pulleys. So now you're being asked about clockwise and counterclockwise. I'm terrible at this, so the fastest way I got to figuring it out, or to like visualize it, is to draw a clock and know which way it rotates. So they rotate in this direction, which means that this is clockwise and this direction is counterclockwise. So having established both of these, pulley A turns clockwise, A does not turn clockwise, so that is false. The system remains still because it is in equilibrium. No, because this is more weight and this is less weight. Pulley D turns counterclockwise is false. All of these will turn clockwise, and all of these will turn counterclockwise. So pulley C turns clockwise is false because these turn counterclockwise, and pulley seat turns counterclockwise is correct because all of these turn counterclockwise. So that is your choice. Right, so last one. Pause if you want to. The figure shows a circuit with several switches, P, Q, and R, placed either in series or in parallel. The switches represent the following statement. P is that X is a divisor of 63. Q is that X is a multiple of 3. And R is that X is even. The circuit needs to be closed so as to turn the lamp on. Answer the following question. The bulb will be lit when X has the following value. Now, I don't know how much you know about circuits, but the only condition for this to turn on is that one of the circuits is closed, not both of them, just one. It can be either this one or this one. So what we're looking for is something that satisfies both R and Q, or something that only satisfies P. If something satisfies both, then that's fine, but we're only looking for either P or both Q and R. Now, having acknowledged that, I'm gonna flip to the next page. Yeah, so this is what I said. We need something that meets R and Q or just P. R is met when X is even. Q is met when X is a multiple of 3. P is met when X is a divisor of 63, so for example 7. So let's start by not by these that are 2, let's start by this one that is only 1. None of these numbers is a divisor of 63, at least in whole numbers. So nobody really meets this criteria. So now we're looking to meet something that is both even and a multiple of 3. So this one isn't even, so let's eliminate that one, and this one isn't even. We did that first because it's easiest to know whether something is even or not even, as long as it finishes in 2, 4, 6, or 8, or 0, it's even. So now life hack, a very easy way of knowing whether a number is a multiple of 3 is that you sum up all its digits, and then if those are a multiple of 3, then it is a multiple of 3. If they aren't, then it's not. So for example, here you have 124, so 1 plus 2 plus 4 equals 7, which is not a multiple of 3 or divisible by 3. So this one does not meet the second criterion. Then 14 equals 1 plus 4 equals 5, which is not a multiple of 3, so this does not meet the criterion, so these don't fit. And then 2 plus 4 equals 6, so 24 is your answer. And that's it. Thank you guys so much for sticking through this. I hope you find it helpful. Again, thank you for liking, commenting, subscribing. I really appreciate it. This was a tough video to make, a bit draining. So if it helped you out, leave a comment, subscribe, like this video, share it with your friends. And yeah, I'll catch you guys next week. Good luck with any tests you might be taking. Feel free to ask me any questions. These are all correct. But yeah, cheers, and see you guys next week.